Hey everyone, and welcome to the Foundry by Forge College. I'm absolutely thrilled you're here with us today. You can think of this explainer as our ultimate engineering drafting session. We're taking all those brilliant, intricate mechanisms you've been meticulously building over the last few modules, and we're finally snapping them all together. Today is the day we finalize our master blueprint for the Capstone project. We are talking about a fully functioning, highly secure, single-node blockchain application. So grab your virtual hard hats because we're heading straight down to the assembly floor. Okay, let's dive into this. In our previous lesson, we wrapped up integrating digital signatures for transactions. Now, what does that mean for you? Well, it means right now, you have a collection of incredibly powerful but completely isolated components just sitting there on your workbench. You've got your deterministic hashing scripts, your Merkle-tree logic, and of course your end-to-end digital signatures. And look, they work beautifully on their own, for sure. But today is where the magic really happens. We're going to wire all of these isolated gears together to create a unified application. We're building a secure, provable ledger that can actually accept and, more importantly, authenticate real transactions. Here's our patent blueprint for today. We'll start with the final assembly line, review our core components, wire the application, run some integration testing, package the deliverable bundle, and finally prepare for consensus. Let's get moving. Section 1, the final assembly line, bringing it all together. Now, real quick, I just want to take a second and acknowledge the hard work you've poured into building these engines from scratch over the past few modules. Cryptography, hashing algorithms, mathematical proofs. Look, these aren't easy concepts, but you've engineered them perfectly. But before we start connecting wires, we absolutely have to establish the golden rule of our final product, and that is reproducible root computation. In a single node ledger, this is literally everything. It's the process of ensuring that identical Merkle roots are consistently generated from the exact same transaction leaves every single time you run the code. It's kind of like baking a cake where the chemistry is so unbelievably exact, the cake comes out with the exact same number of crumbs every single time. If your system can't reproduce the exact same mathematical state byte for byte from a given set of data, well, the entire ledger loses its trust. Reproducibility is the anchor that keeps our final product auditable and verifiable. Moving right along to Section 2, 3 core components, your tool belt. So, what exactly are we bringing to the drafting table today? Let's take inventory. We are going to seamlessly connect 3 existing modules. First, you have your hashing module, which gives us that absolutely crucial deterministic serialization. Second, your Merkle-tree package, which normalizes leaves, builds the tree, and handles those essential inclusion proofs. And third, your signing scripts for key generation and end-to-end verification. Now, here's a trap we definitely want to avoid today, and it's one I see a lot: overcomplicating things. We do not need to invent new logic here. We just need to snap these existing modules together at their interfaces. The heavy lifting, the hard math, it's already done for us. Next up is Section 3, wiring the application, the master blueprint. Now, what's really interesting about this slide is the actual mechanical process of combining our code. Let's walk through the assembly itself. Step 1, wire the flow. We need an endpoint that catches a transaction, hashes it, signs it, and stores it persistently. Step 2, the endpoints. We build functions to fetch proofs and verify signatures so the math actually ties back to the data. Step 3, integration tests, just to prove the machine actually works. And finally, Step 4, run it, document it, and step back to admire your work. It's a highly logical imperative flow, no guesswork involved. Okay, please, if you take one single thing away from this entire explainer, let it be this: always sign the serialized payload, not the raw JSON. I'm serious. Skipping this simple rule is the ultimate rookie mistake. Raw JSON can have totally unpredictable hidden white space or completely different key ordering depending on whatever environment it's running in. If you sign raw JSON, your signature might just outright fail on a different machine, even if the data looks exactly the same to our human eyes. Sign the deterministic, serialized payload, and I promise you will save yourself from brittle tests and endless hair-pulling debugging sessions later on. All right, Section 4, integration and testing, quality assurance. Listen, no engineering blueprint is complete without a rigorous quality assurance matrix. We need to be absolutely certain our freshly assembled gears don't just jam up the second they hit real-world pressure. So the crucial point is, how do we actually verify our outputs? Well, when you submit a transaction, the expected result is a returned object with a verifiable signature. If it fails, check your signature encoding, like hex or base 64, to ensure it perfectly matches the verifier. Now, when you recompute the root locally, it must match the stored root byte for byte. If it doesn't, you'll want to check your leaf ordering. Finally, verifying proofs. Your inclusion proofs must return true. If they mismatch, inconsistent leaf hashing is almost always the culprit there. Just trace the data step by step through this matrix to iron out any bugs. Honestly, don't be intimidated by this. This is exactly where the real engineering happens.
Now, writing boilerplate tests from scratch can be, well, a bit tedious to say the least. So I highly recommend a little vibe coding with an AI assistant right here. You can totally ask an AI to quickly scaffold your PyTest integration test files. Just tell it to submit 3 JSON transactions, recompute a Merkle root, assert equality, and validate the signatures. Seriously, let the AI write all that repetitive test structure so you can save your highly valuable brainpower for the actual application logic and architecture.
Moving to Section 5, the deliverable bundle, packaging your build. Okay, so once your code is running smoothly and all your tests are happily flashing green, it's time to package your build. This is exactly what the project milestone expects from you. And look, having a working app is really only half the battle. What truly separates a novice from a master engineer is documentation. You should really consider it a badge of honor. Your deliverable bundle must include 4 specific things. 1. Clear setup instructions in your README files so literally anyone can run your code on a fresh machine. 2. Your actual application directory or zip file. 3. Your reproducible test output logs. And finally, 4. A security rationale. Speaking of that security rationale, it should be a concise 300 to 600 words. You aren't just writing code here, you are actively defending your design choices. You need to explain exactly why your specific serialization format, your signing process, and your proof generation preserve the absolute integrity of your entire system. If you deviated from the interface contracts we designed in prior lessons, well, this is exactly where you explicitly justify why you made that call.
And finally, Section 6, preparing for consensus, the next frontier.
Let's move to our final thought and see how this all builds into the bigger picture. You've just built a secure, auditable, single-node ledger. It is completely deterministic and provable. But the blockchain ecosystem isn't just one node sitting all alone in a void, right? Which brings us to our final provocative question for this explainer. How does this single node survive and maintain agreement with thousands of other nodes in a highly chaotic, multi-node world? Well, that is the next frontier, and it's exactly what we'll tackle in our next module on consensus mechanisms. Thank you so much for joining me today for this Forge College Explainer. Make sure you head over to forge.college to continue your Web3 learning journey and dive even deeper into this fascinating ecosystem. Keep building, and I'll see you in the next one.